Okay, so today we're going to recap sketching the graph of a line from a table of values. So we've talked about how we use our y-intercept and our slope in order to find points on the graph of the line. What I've already illustrated for you here is the table of values that go with this equation. So all I've done is plugged in the values -2, 0, 2, and 4 to find y values, to solve for y values. So I literally plugged those in, multiplied by -5/2, then subtracted 1. Now I chose even numbers because I knew that would get rid of the denominator, okay, of the 5/2. So as you can see, when I plugged in -2, I got +4. Plugged in 0, I got -1. Plugged in 2, I got -6. And 4, I got -11. Now with these, because of the way they work out, there are only 2 of those points that will fit on this graph. So I have to pick those 2 points and graph them. So I can graph -2, 4. I can put that on the graph right here. And I can also graph 0, -1. Okay, now I can test this with my slope. Remember, this is the slope of the line. So that tells me that if I go from the lower point up 5, then I have to go left 2. So I can do that 1, 2, 3, 4, 5, and then left 2. I can also go from the upper point down 5, 1, 2, 3, 4, 5, and to the right 2. One of the 2 numbers has to be negative. In any case, whichever way you would choose to follow that, this is the line that passes through those 2 points. Okay, so that's all we're doing with these. We are establishing first what our x and y coordinates are, and then we are plotting those on the graph. The next one, got the table of values already established. Plug in -5, I get +4 as the y value. Plug in 0, I get -3 as the y value, and plug in 5, I get -10. Again, I cannot plot 5, -10 on this graph. So the only 2 I'm going to plot are the first and second ones. So the first one, from the origin, I go left 5 and up 4. That puts me right here. And the second point, I go 0 from the origin and down 3. That's my y-intercept. Again, you can see these numbers are spaced out pretty far, and that's because of this slope. Because I'm going from one point to the other by dropping 7 and going to the right 5, or climbing 7 and going to the left 5. And that's what the line looks like. Okay, so now, what does that look like start to finish? So what I'm doing is I'm creating a table of values, x and y. In between the x and the y, I put what is happening to the x to get the y. And that is 1/2 times x plus 4. That will give me my y value. And then I just organize them in an ordered pair. X comes first, then y. Okay, so I can start with something that will get rid of the 2 in the denominator. Any multiple of 2 will work. Well, I'm going to start with -2. 1/2 times -2 plus 4. Well, half of -2 is -1. Add 4 to that. Add 4 to that, you get +3. I'm trying to write the answer down while I'm talking, thinking of the answer in my head. Plus 4, and that's 4 minus 1, which is 3. Plug in a 0. Half of 0 is still 0. Anything times 0 is 0. So I add 4 to that, I get 4. Plug in a +2. Half of 2 is 1, plus 4 is 5. So in this case, I'm going to have 3 points that I can plot on this graph. All three of them will fit. Negative 2, 3, 0, 4, and 2, 5. So I'm going to go to the left 2 and up 3, 0 and 4, and positive 2 and up 5. And I draw the line in. Every time you finish with a line, you don't just put dots on there, you make sure you put the line that connects those dots. Part of that is to test to make sure that you're creating a straight line. Okay, sometimes you can have a straight point that you think fits on there, but it doesn't. Okay, based on your calculations in your table. All right, number 4. And again, you can pause and restart this video as many times as you need to. Number 4. So we are going x. What's happening to the x? Y. And my coordinate. Okay, you can plug in any values you want now. There is no fraction in front of there. There is a negative, and that means that whatever value you put in for x is going to change signs. So if I put in a negative 1, a 0, and a 1, let's see what happens. Well, the opposite of negative 1. So I can't just leave one negative sign in there. This is literally saying negative 1 times x. So I've got a negative 1 out in front. Well, negative times negative is positive, and that gives me 3. Plug in 0. Negative 1 times 0. Anything times 0 is 0. Plus 2 is 2. Negative 1 times 1 plus 2. That gives me negative 1 plus 2, which is positive 1. Just think 2 minus 1. Okay, so all three of those points are on this graph. It is always best to put 3 points. You saw in the first few examples on this page, we couldn't put 3 points because they won't fit. 3 exact points, I should say. Remember, a line is made up of an infinite number of points. So you can technically put other points in there, but they're not going to land on exact grid locations. And that's what we're looking for, exact grid locations. So the first point, I'm going to go to the left 1 and up 3, left 0 and up 2, right 1, up 1. And I'm certain that I can put a whole lot more points on there because this goes directly through the grid corners. And if you somehow ended up with a line that is rising as it goes from left to right, then you did something wrong. This one is falling, and it should be falling because that negative right there tells us that we have a falling line from left to right. Negative slope, falling line. Okay. Number 5. Back to a fraction again. So I'm going to think about numbers that I can get rid of the denominator of the fraction with. So x, negative 4/3, x minus 1, y, and then my coordinate, x comma y. So let's put in a negative 3, a 0, and a positive 3. Negative 4/3 times negative 3 minus 1. Well, negative 4/3 times negative 3 gives me positive 4. Why? Because the denominators wipe each other out, and negative times negative is positive. So that's positive 4 minus 1, which is 3. Put in a 0. As we've seen before, that just zeroes out the first part of this. Negative 4/3 times 0 is 0. Take away 1 is negative 1. And then put in a positive 3. The 3's wipe each other out. I have negative 4 minus 1, which is negative 5. Okay, so my coordinates are -3, 3, 0, -1, and 3, -5. Okay. And we plot those. -3, up 3. First point is to the left 3, up 3. Then 0, -1. And then right 3, -5. And again, using the slope, if I take a look at the slope, that says I'm going to drop 4 and go to the right 3. So 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay, over and over again. From one point to the next, I'm going to drop 4 and go to the right 3. I'm going to undo that because I didn't even come close to hitting. It's hard to draw on paper. It's even harder on this iPad. Okay. Number 6. X. What's happening to the X? Y. And then my coordinate. All of this stuff needs to be included on your classwork page. So again, what will get rid of the 3? Well, let's try a -3, a 0, and a +3. 1/3 times -3, take away 4. Well, 3 goes into -3 exactly one time, but the negative stands, so that's -1. Use a calculator if you need to, if you get fractions that you're not sure of. So that gives me -5. 0, again, always wipes out the first term. So I end up with 0 minus 4, which is -4. +3. 1/3 of 3 is 1. Take away 4 is -3. Okay, so we end up with -3, -5, 0, -4, and 3, -3. All right, and we plot those. Left 3 and down 5. That puts me clear down here. 0 and down 4. And right 3 and down 3. So that line just kind of hangs off the bottom of this grid. Okay. Again, you can pause, slow down, rewind, whatever you need to do to understand each one of these types of problems. I've got an X. What's happening to the X? I'm taking 1/2 of it, and I'm adding 3 to that. I've got a Y. I will have a Y. Okay, so again, sometimes the makers of a worksheet, the makers of a problem are going to give you the X and Y value or the X value to plug in. Well, I'm kind of doing the same thing for you, but I'm making you think about what will get rid of that denominator. So I could go -2 because that's a multiple of 2. I could go 0 and I could go +2. I could even go +4. I believe that will still fit on this graph, but I'm only going to do 3 of them. So we take half of -2 and we add 3. Half of -2 is -1. Add 3, I get +2. Half of 0 is 0. So you notice that I'm always picking 0 because I know that zeroes this out. It makes it a simple addition problem. 0 plus 3 is 3. And once you see a pattern too, you'll notice that I'm going up by 2 every time here. Okay? And it appears as though this is going up by 1. So this should be 4. But let's do that and make sure that it's 4. Half of 2 plus 3. Half of 2 is 1. Plus 3 is indeed 4. So my coordinates are -2, 2. And 4. Okay, a negative 2, 2. That means it's a unhappy 2, 2. Get it? All right, so left 2, up 2, 0, 3, and positive 2, 4. Okay, and the last one. And then when you're finished with this, make sure you open up your classwork that's attached to this assignment and do the same process with that. Okay, you are putting points in, determining what the y value is going to be based on your values that you put in. All right, so nothing to get rid of here. So the best thing to do is to always pick fairly small values. And so I'm going to pick -1, 0, and 1. When I don't have fractions that are going to cancel denominators out, I pick small values. Why? Because I want to hover around that origin to start with and hope that the points stay on the graph. So I have -4 times 1 times -1 plus 4. Well, -4 times -1 is positive 4. Now this one is not going to stay on there. That's 8. Okay, so that goes off the graph. -4 times 0 plus 4. That gives me 0 plus 4, which is 4. And -4 times 1 plus 4. And -4 times 1 is -4. Add 4, you get 0. Okay, so I got 2 points that can fit on this graph. I could have used 0, 1, and positive 2 for my x values. That still would have worked, but I only need 2 points. So the coordinates are as such. And remember, these are called ordered pairs, and they're ordered in alphabetical order. X comes before y. And we always, from the origin, go in the x direction first and then in the y direction. So my first one I can't do. It goes off the graph. Second one I can do. Over 0 and up 4. And then the third one, right 1 and up 0. So it lands right on that. -4 was my slope. And there it is. And that's all there is to finding points and graphing those points on a coordinate plane.